Hello, my name is Carlton Rees, student number N10750796, and this is my portfolio 4 question. As you can see here, I have a diagram of the question, and then I have a second diagram which I've combined the two systems. And we have a J equivalent term. If we sum the forces around the J equivalent term, we can see that we have our force, which is being opposed by the inertia, by the spring, which is interacting with both our N1 and N2 theta M direction and our theta LS direction. Hence why we have the subtraction here. The dampener, however, does not play any effect because it's only attached to our JL inertial system. If I continue with this equation, I get a standalone equation for Tm of S. Then if I do the same thing for JL, we have the inertia of JL, the effects of the dampener, the effects of the spring K2, which is only touching JL, hence why it's only direction theta L of S. However, K1 is interacting with both theta L and N1 and 2 theta M because it's connected to our J equivalent mass, hence why there's both terms there. We do this, we get an equation for theta L of S. This will be useful later. If we sub this as well into our T M of S, eventually we get a standalone equation for T M of S. If we do the Kirchhoff-Schwarzschild law at the motor, here are some equations for our terms. We have 0 equals E of S, take R, I of S, take VV of S. If we sub in these equations here, we get E of S equals R and KT, T M of S plus S, KB, theta M of S. If we're able to sub in our T M of S equation from above, we get this equation here. Since everything has a theta MS term, we can then divide by theta MS, getting us this. Again, from earlier, this is the important part. Since we know that theta LS equals this equation, we can get theta M of S. We can then sub in that here to get our theta L of S, and multiplying by this section here. Then since the transfer function calls for theta L of S on top of theta AS, we can then flip our equations, hence why the K1, N1, and N2 is on top here, and why this term here is now dividing 1. If we then sub in our values, you can see here we go through each step, eventually arriving at this part here where we have 0.0018 S to the 4. We simply want our highest power of S term at the front to be singular, to be 1. We can then multiply top and bottom by 555.556, which will in fact give us our S to the 4. We do that by every term, again multiplying top and bottom, and we get our final answer here for our transfer function.